Excellent. I think we're live. How's that for demo day, everyone? Hopefully everyone enjoyed that. Welcome to the Hydrogen room, which is clearly the best room you want to be in. So hopefully you can join us for the next 30 minutes whilst we do some Q&A with the 3 hydrogen startups that we have. So as you can see on my screen, we've got Sungreen, Tulika Raj representing Sungreen. We've got David Cassidy from Clean Hydrogen Technology. Just definitely wave, say hi. And then we've also got Alex Lewis from Electroactive. So how this is going to work is I'll have a quick 5-6 minute Q&A with each of the startups. If you have a question, please put your question in the box underneath the video player. We'll try and get to as many questions as we can over the next 30 minutes. And we really look forward to your participation. So I'll quickly move into speaker view and get Tulika up to have a chat. Hey, Tulika.
Hi, Abs. Great to be here. How exciting.
Yeah, it's been a great demo day. Loved your presentation. And I've got a few questions already lined up for you. So first of all, let's talk a bit about the competitors that you have at Sungreen.
Absolutely. Thanks so much for the question. Look, let's emphasize what Sungreen H2 is doing. We're excited to bring to market our platform technology, which can be applied to all existing types of electrolyzers today. And what we're doing is we're incorporating high performance, low cost materials into electrolyzers. So what we do is we use nanotechnology to dramatically increase the surface area that's available for the water splitting reaction. What that means is when you build an electrolyzer using our materials, these show world leading performance. This is how we're able to double hydrogen production and use 10% lower energy consumption and use 30 times lower platinum group metals. Now there's a number of different types of electrolyzer technologies in the market. Alkaline and PEM electrolyzers, proton exchange membrane between them hold almost the entire market share today. And there's a bunch of other emerging technologies like solid oxide, anion exchange membrane, HHO, membrane-free electrolyzers, you name it. The green hydrogen market is exploding. What this means is as long as the technology is using metal or mixed metal electrodes, we've got the components that can help them incorporate this kind of performance into their ultimate product. At the same time, we are directly working with electrolyzer manufacturers who are our customers and with the world's leading industrial and energy companies to scale up our own solution and bring this to market. So hopefully that gives a good sense of where we're playing in the competitive value chain.
Definitely does. I saw in your presentation, and one of the questions that has come in as well is you talk about getting to less than $1 per kilogram. Do you want to talk a bit about when do you think that will be and what do you think is needed to kind of get to that?
Yeah, I was going to say one word, but it's not. It's one phrase answer. What do we need to get to low cost green hydrogen? We need low cost electrolyzers with high performance. There's 2 things really required for electrolysis. We essentially need water, which needs to be split into hydrogen and oxygen, and you need a supply of renewable electricity. It's only because renewable electricity is today so vastly entrenched in our energy ecosystems and has come down so dramatically on the cost curve that green hydrogen has actually become a possibility as a zero carbon source of renewable fuel. And this is exactly what's needed. We need renewable costs to keep coming down. So not everywhere in the world is going to be, let's say, cost competitive in terms of renewables. But let's talk about Australia, right? One of the lowest cost bases for renewable electricity, resource rich with wind and solar. This is exactly what's required to bring low cost green hydrogen to market. At the same time, electrolyzer technology has to keep up because the lower amount of renewable energy electrolyzers consume, the more efficient they are. The easier it is to get, we're talking about terawatt hours and terawatt hours of renewable electricity required to actually meet some of our green hydrogen objectives. So we really need the electrolyzer machines that are making all of this possible to become low cost and efficient at the same time, which is exactly what Sungreen H2 is doing.
And Australia is a great place for that because we've got abundance of renewable energy, loads of water and space. So hopefully it's a big market for you as well.
Absolutely.
As part of the technology that you mentioned, you did talk a bit about some of the patents that you already have. Do you want to tell us a bit about those patents, and do you see this as a bit of a moat that you're creating around yourself?
Yes, absolutely. Thanks. So What we're doing is we have nanostructured materials for use in electrolyzers. As I mentioned, there's a few different technologies. So what we do is we patent each of the set of materials that we've made for each of these types of technologies. The company has a broad patent suite, which is also constantly expanding in size as we go along this journey of bringing more and more solutions to the market. And that's how we protect ourselves with both a combination of patents, but also some trade secrets.
Excellent, excellent. I'll ask one more question before we can move on to the next company. As a startup, we really talk about the vision and what you're trying to achieve, what the impact you're trying to make in the world. Do you want to talk a bit about what SunGreen's vision is?
Sure. SunGreen H2's vision is for the future to be decarbonized and democratized with energy from green hydrogen available at wide scale and low cost. We really want to be the leading supplier of green hydrogen solutions to the industry, revolutionizing net zero emissions, but most importantly, building a sustainable future for the next generations. That's really our broad vision for the company.
Excellent. That's something that we can all get behind. If you do have more questions for Tulika, please put them in the chat. We'll get to a final kind of quick fire round for the last 5 minutes. But in the meantime, thank you, Tulika, for your insights and for answering some of our questions. Next up, we've got David Cassidy from Clean Hydrogen Technologies.
Hey, Abs.
Welcome, David. Again, another fantastic presentation, really interesting. I'd love to kind of dig a bit deeper into clean hydrogen technologies and your background a bit as well. You've actually got quite a few questions coming in, so that's going to be answer a few of those questions. Before we get into those, let's talk a bit about clean hydrogen technologies and the and where you sit in the market and maybe some of your competitors are maybe sitting around you.
Yeah, of course, Abs. Thank you. I guess if you're going to talk about competition, you need to talk about what is the incumbent in the market, which is steam methane reforming. And one of the great things about steam methane reforming as a competitor is it's cheap and it uses very little energy. I mean, the bad news is it produces 12 tons of CO2 emissions and you need 20 tons of water to produce a ton of hydrogen. So if you're going to compete with steam methane reforming, you need a solution that uses the same or less energy, produce at the same or less cost, and also have no emissions. So those three attributes are the cornerstone of our competitive capability in this market. There are other important solutions which will have a role in the future. Electrolysis will have its role unquestionably. But nonetheless, when you're looking at the pure mechanics and physics of reactions, pyrolysis with our unique patented catalyst is the most competitive solution. There are other companies out there that participate in pyrolysis or cracking solutions, but to the best of our knowledge, Abs, none of them has the efficiency that we realize from our catalyst in the quality of the products we produce and the efficiency of our cracking and the least amount of energy required. To simply put the case forward, when you crack methane, CH4 into carbon and hydrogen, they're desperate to get together again. Our catalyst keeps them apart and it makes sure that carbon becomes valuable, which in our case is conductive carbon. And then we got the highest quality hydrogen to come out the back. And again, to the best of our knowledge, nobody does that as well and as efficient as us.
Excellent. Amazing. I had a really good analogy around that. I was like, when you're dating and you want to kind of keep people apart, it's like you're kind of keeping those two atoms apart. So one of the questions that has come in from Declan Berg from Hazer Group. So he says there have been a wide range of catalysts developed for H2 evolution. However, many of them have been limited by catalyst price fouling. How do you plan to address this?
Yeah, no, I mean, we welcome the question from Hazer Group, who are doing something similar to us. And you know, it's great that lots of companies are working in the space that we're working in. With us, when it comes to fouling from the catalyst, it comes down to the selection of the elements and the molecules in the catalyst. And fouling happens because they're reactive in a bad way and or they decay in their efficiency at cracking methane. We've spent many years now taking feedstock of flue gases from industry, as well as natural gas, propanes, acetylenes, methanes. So we understand now that the shelf life, which means that the propensity of our catalyst to foul is very low. Our catalyst, we've run it without requiring replacement and with there being no decaying effect for days. So actually, this question is important to us, Abs, because the most important attribute and capability in our business that differentiates us to be the best at what we do is our catalyst. And we know it's unique for two reasons. Number one is we've worked with Evonik, the biggest catalyst builder in the world, and they produce catalysts all over the world. And to the best of their knowledge, they've not seen anything like this. Number two is the work that we've done on prior art search and analysis in the submission of our patents and their associated trade secret capabilities. So we know we're unique, and we also know we're unique and more compelling with less fouling than anything out there, because our cracking efficiency, that means the amount of methane we can crack is higher than anything else out there. We've gotten as high as 97%. And importantly, the quality of our carbon black is majority conductive carbon to build batteries. All of these things and the shelf life maintaining effectiveness is the basis for us knowing about the quality and the low propensity of our catalyst to foul, and for it to maintain a high shelf life in operation.
Excellent. Very, very comprehensive answer. I've got one question coming in from Ricardo Costa, who's an excellent energy program manager for Energy Next. He talks a bit about the conductive carbon market. Can you talk a bit more about what that is, and is it growing as fast as the hydrogen market?
Yeah, it's actually growing faster than the hydrogen market, in particular if you got solutions which are non-toxic, non-CO2 emitter solutions. Today, the predominant aspect of conductive carbon, which is one of the many types of carbon in carbon black, comes from processing petroleum, natural gases in a complex, toxic process with lots of emissions, which include CO2 emissions. So we today produce conductive carbon mostly. We've got a certain amount of carbon nanotubes we also produce, and we produce that with no emissions. The good news is that there are big companies around the world, and largely will produce in the US, where some of the biggest carbon black companies are producing today. So they will take our carbon black as a wholesale feedstock and feed it into their existing refining process. But of course, it doesn't have the ugly emissions of having been produced from petroleum and other things. We slot in at step 12 in a 20-step process, where the final steps are the refining by the refiners. So as that conductive carbon is then in the right format to manufacture batteries. So apologies, Abs, the long way to answer your question is the market growth for batteries is enormous, even more so than it is for hydrogen around the world. And our conductive carbon is specifically designed to a specification that meets battery market, production, and its increase over the next 10 years. Very
comprehensive. And one last question before we move on to the next company is from Evan Wilcox from Patent Finance. And he asked, do you own the technology or license it? And if it's the latter, where is it from?
Yeah, so we own the technology and we don't license it. How we actually work is a different commercial model and business model. We sell our hydrogen wholesale and we sell our carbon black wholesale. And the reason we've taken that path, Abs, is that it gets complicated selling your technology. People then have to know how to operate it, operating procedures and processes. Our go-to-market is we're guaranteeing a specification of hydrogen and guaranteeing a specification of conductive carbon black. That makes it easier for customers to consume our products. So our products are literally the outputs, not our technology, not our catalyst. That's our responsibility to make sure that we use those to produce quality hydrogen and quality conductive carbon black.
Excellent. Thank you, David. We'll leave it there. There's a few more questions, but we'll try and get to those in the rapid fire part. But if you do have more questions for David, then please put those in the box, and also for Talika as well from Sangreen. If you've got more questions, we'll get them up at the end as well to answer those. But in the meantime, thank you very much, David. Next up, we've got Alex Lewis from Electroactive. Welcome, Alex.
Thanks. Great to be here.
Another, again, great job on the pitch at Demo Day. We've got 3 questions kind of coming in, and I've got a couple of mine. But let's kick off with what you did mention in the Demo Day, which was you're raising $1.2 million. Tell us about why you're raising it, what are you going to do with it, all the fun stuff around that.
Yeah. The 1.2 million is really going to support our pilot demonstrations, which are going to be a big inflection point for our company and lead us to a Series A fundraising round closer to $10 million in early 2023. And we're going to be using these funds to really build our business development team and add additional technical strength for hiring experienced staff for conversion of our pilot projects into early customers. And now for these important pilots that we're lining up, we really have a pipeline of around 4 pilots that are going to be executed with a strategy to demonstrate the utilization of increasingly complex food waste from liquid streams and from solid food waste. And we've chosen to partner across 4 different verticals with wineries, grocery chains, municipal food waste, and energy utilities. And these will demonstrate and validate the ability for us to produce not just a few kilograms in these pilot modules, but we'll have a scaling factor in being able to replicate these units to then show how we can produce them on the orders of hundreds to thousands of kilograms a day as well.
Following on from that, I want to touch on one of the questions that, again, from Declan Beck from his group. Thank you for a question. I'm sure you get this quite a lot in terms of, does this model that you have create a perverse incentive to generate more food waste? How do you kind of see that kind of playing out?
Yeah, I actually have not gotten that question before, but I can definitely see why that would be a concern. But for us, that's definitely not, what we're creating, and it doesn't end up working that way because generating waste is just costly to the generator. So there would be no incentive for them to really continue to generate it because it's still a cost to them, whether it's an individual or a company. And then just as our company kind of mission and being a public benefit corporation, we fully support all the efforts to kind of reduce food waste at the source and on the front end, and then get edible food to those in need. But it's just simply impossible to stop food, waste generation altogether. And with the growing population potentially reaching 10 billion by 2050, rising standards of living, 70% of populations being located in urban centers, there's just going to be still massive amounts of food waste. And we need to find the best, most valuable way to get to deal with that waste that most positively benefits the planet as well. And that's what we're striving to do as just part of the overall value chain.
And just to follow up on that, what's the advantages to your approach to hydrogen production, and what's some of the positive impacts that you talked about, like the waste part? Is there any other positive impacts you might want to touch on?
Yeah, similar to the other companies here, we're all producing hydrogen renewably, and ours as well as can actually go negative as well. We were actually removing 82 tons of CO2 per ton of hydrogen we produce, because we're preventing food waste from going to the landfill and emitting methane. And then the hydrogen produced can offset fossil-derived hydrogen, which David highlighted emits quite a bit of CO2, or can offset gasoline and diesel. So this really helps us, make the overall process even more renewable and make hydrogen have a bigger impact there. Our system also generates some byproducts that can actually be positive and contribute to regenerative farming or urban green space development to bring additional value to the surrounding community. And then looking more specifically at our technology, because we're using waste as a feedstock, that also gives us somewhat of a competitive advantage, because that can be acquired for zero or even negative cost. And it also lowers the external amount of electricity we need to put into our system. And then finally, we're also not just producing hydrogen, we're providing this waste management solution, which provides additional value in our target applications. And for these other waste to hydrogen pathways that are out there, our on-site and distributed approach requires a lot less scale to be economical, and really works well with the high liquid content present in most food waste.
Excellent. Got a really interesting question coming in from Hiroshi Shimada from Mitsubishi Corp. Thank you for your question. Who do you think is going to be your user or customer, and how do you look at scaling your business?
Yeah, initially we're targeting food companies that are already using fuel cell forklifts in their distribution centers, since fuel cell forklifts are the most mature fuel cell hydrogen using market. And many of them are in the food industry. So companies like Walmart and Amazon and Kroger in the US, to name a few. And so we can come into there, use the waste that they have to make hydrogen to power their operations. So kind of having both sides of the equation in the same spot. But we can certainly grow from there. And our target is to work with waste haulers, private and public waste haulers, to co-locate at their transfer stations, because they're the ones that are processing the much larger volumes of waste, because 80% of food waste is produced in the home or at consumer-facing businesses like restaurants. And so we can help them manage that food waste at their transfer stations, reduce the weight by more than 50% to really minimize the transportation that has to happen, and then start producing that larger volumes of hydrogen that can open up larger transportation markets to supply public transit fleets and other heavy-duty transportation, and eventually fuel cell personal vehicles as well. We can certainly expand beyond the fuel cell and transportation and markets into the other industries where hydrogen is being used very broadly in other refining, fertilizer production, even in electronics production and other food processing. It's just such a universal commodity that we can enter into those markets as well in the long term.
Excellent. And one more question before we can bring you all back up is from Ricardo Costa. How does your solution compare with competitors in terms of cost per kilogram of hydrogen?
Yeah, so for us, we certainly have a target and are on a path to reach the number that everybody tries to get to in the market, which is at least $2 per kilogram for production costs. But because we're not really producing hydrogen as a commodity, it's not as central to our business model and our revenue streams, where we're solving this other waste challenge for our customers. And so that enables us to commercialize earlier before we fully realize all the cost reductions that we can in the future, so that we can come in earlier and absorb those higher production costs because of the waste benefit that we're bringing there, while we improve on our path to that $2 per kilogram number.
Excellent. Thank you, Alex. Please all stay online, because I want to kind of get you all back up on screen to answer a few of the questions that are coming in. So if you do have a question, either for Tulika at SunGreen, David Cassidy from Clean Hydrogen Technologies, or Alex Lewis from Electroactive, please put them in the chat box, and we'll kind of get to as many as we can. So Tulika, I've got one question coming in, definitely around the business model for SunGreen. Do you want to talk about how that looks like?
Yeah, sure. So currently the company has two business lines, right? The first is electrolyzer components, which we are supplying to our customers who are electrolyzer OEMs or manufacturers. And the second one is in a manufacturing partnership to bring a scaled-up version of our electrolyzer concept to market, for which we're working with industrial and energy companies and also system integrators. So for these two business lines, on the components side, we really make the margins for those components. And for the systems, of course, these are manufactured in partnerships, but what we would hope to realize is recurring revenues and sales from our components being placed into those electrolyzers as well. So that's broad brush strokes, the business model of the company.
Excellent. If you want to know more, please get in contact with Tulika. David, another question on your catalyst. I think everyone seems to be loving your catalyst. So can you tell us, this is from Declan again, Declan Berg from Hazer Group. Can you tell us a bit more about your patented catalyst? As a metals chemist, he's super interested in this.
I can tell as much as I'm allowed to tell about our patented catalyst. And again, I welcome Declan's questions from the Hazer Group, who are doing something similar. But what I can say is a little bit more on top of what I've said before. And maybe I'll set some context for Declan to say, originally our catalyst wasn't trying to produce, hydrogen and conductive carbon. We actually originally were trying to produce carbon nanotubes from flue gases from heavy industrial processes. So we came from a very different direction from companies like Hazer and Monolith and all these other companies out there, some of which are catalysts, BASF and so forth, because we tried to produce carbon nanotubes. And we did produce some, Declan, but not that much. But actually what we did very well is produce a lot of very high quality conductive carbon, and we've done a lot of specification analysis on it. And of course, by default, we got quality hydrogen. Now we're taking a different approach from Hazer. I mean, Hazer, you're solving biogas challenges and a whole bunch of stuff. We're working off feedstock, which is natural gas. So propanes, methanes, acetylenes. So if you consider the nature of where we come from, we've really tried to stay to molecular structures that are predominantly inert, but it's how they actually work once it's cracked apart, the methane. That's the key quality in our catalyst. So to answer the question in a very roundabout way, Declan, without giving away too much, where we've come from, carbon nanotubes failed, very good at producing conductive carbon and quality hydrogen. That's really been our success. And at the same time, having a very high efficiency in cracking the methane and the acetylene and the propanes and the butanes, where we're getting it as high as levels as you'd see in plasma cracking, so up to 97%. All of those attributes come from our catalyst. What's the molecular formula? Sorry, I can't tell you that, unfortunately, Alex.
Excellent, excellent. You can have some secrets in business. I'm going to ask 2 questions to everyone, the same one. First question is, I want to get your views on this, Alex, first, is what's your biggest challenge at the moment?
Yeah, our biggest challenge at the moment is getting to scale as fast as we can, because there's so much interest in this area for all our companies here that people are wanting low-cost renewable hydrogen. And so we're trying to get our team fully assembled, get the funds we need to really execute on these pilots. But the remaining, I guess, technical hurdles or the demonstrations that we need to do is that, since we haven't been around for a while, for that long, that just being able to demonstrate the system operating, on the order of years is something we really want, that we're getting to be able to show it operating reliably for that amount of time, show the effectiveness and efficacy of our preventative maintenance procedures for keeping the system operating and not fouling. And so those are things that our pilots are going to also allow us to do, to get some longer term data, showing it out in the real world, to show the utility of this at a scale that people can appreciate and really accelerate us forward.
Tulika, same question to you. What's your biggest challenge at the moment?
Sure. I think one challenge we've overcome, right? Remote prototyping a hardware solution during a pandemic where borders have been closed has been really eye-opening. We're exceptionally proud of the prototype that we have built, which is operational today and which we're working on demonstrating commercially with some of the leading green hydrogen players, in Australia, Europe, US. Apart from the obvious challenge of, scaling up fast, one hopes that this pandemic-related challenge doesn't continue to last. But at the same time, also, we're bringing a technology that's extremely breakthrough from the lab into the industrial space, and we're constantly seeking partners, industry partners, to help us commercialize and demonstrate our solution. So I would say that to get more and more of those into the pipeline, it remains an evolving challenge.
Thank you, Tulika. And David, what's your biggest challenge at the moment?
Well, today I've got my material scientist in South Africa, one in Singapore. I've got my head of biz dev in Toronto, my patent specialist in California. COVID is our biggest challenge today. Moving around, trying to get people in the one place. There's a lot can be done across Zoom, and we've certainly become very efficient in this world. But I can tell you, Abs, we're not moving quick enough because we can't move quick enough. That's my biggest challenge today, Abs, is getting people moving around the world. I've got a PhD in how you get people around the world using COVID, challenges and getting vaccinated. That's it. We'll move quicker, the quicker that we can move.
Excellent. So in terms of scaling for electroactive partnerships and hopefully trying to get people together to actually collaborate and accelerate for clean hydrogen technologies. And finally, very quickly, I want to just kind of get your crystal balls out to kind of look a bit into the future. So if we were having this conversation again in 3 years' time, where would you be? What impact will you have made? And what would the kind of future look like? So I'll start off with you, David, first on this one.
Sure. In 3 years' time, there'll be a couple of things that will have happened in our business. First of all, our reactors will be in use in hydrogen hubs in the US, predominantly California, fueling heavy transport, predominantly heavy trucking, mostly in the US. Separately, we'll also be part of a first to second stage scale of producing hydrogen at scale, which is in part being then pushed down existing pipes in a mix of natural gas and hydrogen, increasing the overall energy efficiency in the sort of delivery of the end energy to electricity plants and other end users around the world. Importantly, both of those end user models will be generating income. At that stage, we're cash flow positive. And we're actually a business of just building reactors, Abs, because we've done the hard work already. We understand our tech, we've proven it, we know how to scale. At that stage, all we're doing is rolling out reactors to work in single sites or together, thousands of reactors working together. That's our business in 3 years' time.
Excellent. Alex, same question. 3 years' time, what is Electroactive look like?
Yeah, we'll have our initial commercial sites operating that have been rolled into commercial customers from our pilot demonstrations, to have our initial customers like David in California, but also in the Northeast in the US as well, as where our first customers will be. And so the 3 years time, we'll be now expanding out of the country into the other attractive markets like Japan and Australia and others that are really pushing forward hydrogen, and also have some activities around food waste. So getting our next iteration of commercial systems out of the country and into those other areas, as well as now getting into the optimization of our manufacturing pipeline, because that's so core to what we're doing, and similar to SunGreen, with ours being kind of a stack and modules that are going to be replicated to make larger systems, getting the manufacturing process down, and with us also having a very novel process in being this hybrid biological electrochemical system, getting that manufacturing down so that we can make these larger scale systems and stack the units together. That's where we'll be really getting our optimization in place at that time.
Thank you, Alex. And final word to you, Talika. 3 years from now, what does SunGreen look like?
Thanks. SunGreen H2 aims to be the leading supplier of green hydrogen solutions to the industry. We see ourselves as supplying the materials and being incorporated into the leading electrolyzers that will be out there, part of the 100 gigawatt landscape of electrolyzers to be installed. But more importantly, with our own design version of an electrolyzer as well out there being manufactured and installed in partnership. Not only that, our advanced materials capabilities, as I said, we have platform technology. We see ourselves expanding from electrolyzers into fuel cells and hydrogen panels. So watch this space.
Excellent. And I'm really personally excited about how hydrogen is going to evolve over the next 10 years. I think we need this solution, hydrogen, to work to kind of displace some of the fossil fuels that are currently in our system. And as you see here, we've got 3 amazing different types of technologies that are playing a role in making a difference. So I'm quite keen to see how you all progress. So I'd love to thank you, all 3 of you, for your time this afternoon. And I'd also like to thank the audience for their questions and for participating. We can't do these programs without the support of our community, and a big thank you to them. So wherever you are in the world, have a fantastic rest of the day, and we'll see you very soon at our future event. See you all.
Thanks, everybody.
Thank you all.
Thanks, everyone.